Thank you. And I think I'd like to thank Tui and Yibi as well. Yibi is not here, but it's amazing how you managed to come up with that, the whole organization of that. There was just an idea to start with, and then thanks to you and thanks to Yibi and others, things have happened in a very nice way. So it's just want to acknowledge that. So I'm going to give you a quick overview and landscape analysis a bit of the analytical flexibility and motivation aspect. I don't have any financial over disclosure. And it's just to, this is it sets in the problem of reproducibility in general. It is one of the factors of reproducibility. And this is just one of the papers that, analyzed hundreds of studies and didn't see any of the consistency across all those studies. And I think that's an important aspect of, each of those individual studies may have maybe significant, they're published, but still at the end, it's difficult to do the consensus aspects of all across those things, and that's in the field of unipolar depression. And you probably all know that, as when you start to actually try to reproduce papers or findings, well, you don't always manage to do so. This is one of the early work by Brian Nosek that actually led to the open science framework development, where all those red points actually have are kind of have unreproduced findings from the different papers. So it's a widespread issue, and we can, and many labs are actually starting to think, and it's been a while thinking about those issues, and how do we make sure that the work we do is actually is reproducible or replicable, even better, and that's has come up in many papers now. So I want to give you a little bit of an overview of things in that space. One of the aspects that in this particular work, for instance, we were not able to reproduce a meta-analysis result, which was a bit more concerning, even more concerning, because when you think of a meta-analysis, you're thinking, okay, that's taking a lot of the papers of the field, and still, and even with that, one of the things that I want to point out is that we actually tried many different pipelines for trying to produce the meta-analysis results, and that failed. So that's just one personal example of this issue that we have in the So when I divide, I teach reproducibility issues at McGill, and when I divide the word for those reproducibility issues, I've usually tried to divide it into statistical procedural problems, sample size issues, and all those things, issues in data and software, and possibly the cultural aspect and the incentive of academia that is also a factor in those reproducibility problems. In this workshop, we're going to focus on data and software, in particular software aspect, So in that data and software aspect, there's a number of things that can happen, so research software issues, some example I'm going to go through, and there's a number of possible places where things can go, the choices you make, it's unclear on what are the impact on the result that you will get. So this is a landscape analysis soon to be published in Imaging Neuroscience, where you see that there's a choice of this operating system aspect, then there's a choice of the tool dependencies, what is actually installed on your system when you're launching those things, those pipeline. There's the actual choice of the tool and the pipeline, do you use Free Software version 7, or do you use ANT, or do you use FSL, or things. And then there's a choice of tool parameters. Maybe those things have to be parameterized depending possibly on the data. And then all those things, and if you do the multiplication of the choices, you have a kind of a wide space of possible choice. So the question is, what is the impact of all those choices on your findings and your results, right? And that space is quite large, and in this workshop we're going to hear about BAPS, NeuroCI, actually NIPOPI, NeuroDesk, and BrainLife. So that's one of the four things that actually can help you in assessing that analytical flexibility problem. So the question is actually not neuroimaging specific. And that's important to understand, like in life science in general, in science in general. So those are two examples of software issues, I would say. I mean, I won't describe those things, but this is just to tell you that when you're reusing a software that's come from somewhere, if that software hasn't been well tested, or if you're not sure what it's doing, that can lead to some problem. And I won't describe the stories behind that. Come to me after. I can describe that. Or when the software is kind of a poorly designed and is leading to some possible errors. So this is not the topic. I just want to mention that topic that, sometimes software have bugs. There are difficult things to do, and it's not no small feat that we have all those things. But sometimes they have bugs, sometimes they are badly used, and I just want to acknowledge those things. This is not the topic of the workshop again. It's really about the choices you make across the different software. This is an example in machine learning with different algorithms for optimization being recoded by different groups. And you see the very extremely different results that you get from when you recode those algorithms that are for optimization of learning in deep learning, and and you see different. This is the same algorithm. This is an algorithm published somewhere with pseudocode, and people recode those things, and they found extremely different results across those things. So that's an example outside of our world, but that's important to kind of understand that it's a very general problem. So let's go and see what has been published, or at least some of what has been published. I'm sure there's many more things. Let's say for just T1 imaging. And T1 imaging, this is one of the early things that I think it happened at a hackathon a very long time ago, where Erin Dickey and I think Dave Kennedy were looking at the size of the left caudal anterior cingulate, and they're looking at, oops, I'm sorry, how do I go back? This way. And they were looking at the correlation that you get across subjects for that specific volume, with when you're using ants and when you're using free software. This was an old version of free software at the time. And correlation is pretty poor. And you can imagine that this will have some consequences in the results. This is our own lab, Nikhil Bharat is on the top front here and co-organizing this workshop, looking at using different software and civet free software, and looking at the correlation of region volumes across the population, and showing that connectome aspect is very different across those tools. And this has actual consequences. This is one of the examples, and there are many of those, where this is an analysis done by different software on whether that is ASD versus control have different organization of the brain, of structural organization of the brain, and you do find different actual results, so different scientific conclusion depending on the software you've been using. I won't talk about that because Tom is here. I think he's going to talk about it. But this is just one of the things that you have to think about. Maybe if you are in a machine learning sort of a framework, then maybe there is capacity of a ground truth, and maybe there's not. So if there is capacity of a ground truth, that's kind of easy to choose the software, right? But in many cases, we are not in that area. So I will leave that kind of multiverse / vibration things to say, there are possibly ways of reusing multiple results from the multiple pipelines. In fMRI, this is a very old and I hope that some of you have already seen that. This is always a beautiful early work by Joshua Karp, looking at taking from the literature, looking at the method section of the literature, and those method sections had, different things. So we've used, for this kind of a Gaussian filtering, and then we've used this sort of registration, and so on and so on. So there are many choices, this kind of bold response, and so on. And he's looked at all the possible choices, made almost 8,000 pipelines, and used those pipelines to actually analyze the same data set. And you find that the maximum response in the brain can be pretty much all over the brain. So it was a bit concerning. This is actually a slightly biased and not really good visualization, most of the results are still in that area of the brain. So I think, it's, I don't want to depict something that's worse than it is. But it still is concerning that there are very much a large variability across those pipelines in terms of the result. This is work by Alex Bowring, Camille Moët, Tom here, and looking at the difference between FSL, AFNI, and SPM on the same data set, and looking at the variation of the T statistics maps and the distribution of those things across those things, and basically concluding that there's quite a bit of a difference over there. Let me skip this one, but I just want to say one thing. It's about software parameterization. So when you're choosing a software, and this is what an early work of early, not very early, but like, a work from on the cluster size test, and that cluster size test, you have to define a threshold to define the cluster. Depending on that threshold, software would respond very differently and sometimes very wrongly on how, if that cluster of voxels is actually significant or not in an fMRI data set. So that parameterization is very hard, and sometimes those things are, you just take the default parameter because like this is the thing that you may not have, be fully aware of all the literature on those things, and like it's very hard to actually choose. And that thing is like, more recent, is this idea of like, you send the data set to 70 labs. That's a beautiful work, I think, kind of like a sociological work rather than the technical one in some sense, where you send the data set to the wild and you look at what are people responding and whether those results will be similar or not. So there's a bunch of results that are in 50 labs that have found like correlated results in some ways. So this is an fMRI data set, and other results that are maybe due to mistakes or like or different depending on how things are done. And when you threshold those maps, even within the area that has correlated results across labs, then you don't, you find like 40% would say yes, 60% would say no, we can reject that hypothesis. So if you think of what is in the literature, that variability of pipelines that those 70 labs have used, and has a real impact on the literature, on the results. And that's the motivational aspect that I want really you to catch and to think about when I read a paper, how results would differ if some other pipelines would have been used. And that's the problem, and do we have an idea of how robust those results are with pipelines? This is our own work like for the lab, the same sort of things using dynamical connectivity. And I won't tell you the whole story again, but what I think is interesting is that we kind of compare that variation of that variability due to pipelines to the actual biological variability of functional connectivity. And mostly, this is the same kind of order of magnitude. And also extremely large possible variability in terms of pipeline, as much as biological variability in this instance. Diffusion-weighted images, there's beautiful work as well from a very large group led by Maxime Descoteaux in Sherbrooke. And that paper is showing basically that depending on and to be fair, it's a very difficult thing to do. So it's not at all absurd that things will differ. But the way those tracks are be defined will be very again dependent on the details of those pipelines. Right. There's also, and that's more hidden, it's more like, difficult. There's also like even across operating system and across, this is a great early work from Tristan Glattard, now at CAMH, showing that even if you use the same container on the same data set, you may have like, changes in the results. So that's a segmentation done on two different clusters that have different operating system with the same container. And the thing is that, even those containers are still relying on some libraries of the operating system, and those libraries will have, different versions, and those different versions will lead to different, like a numerical noise aspect. So that's another aspect which is not easy to grasp. And so the question, of course, is how much variability you get. I can tell you that in some cases it has significant variability. Data themselves, I want to moving away from the software aspect a little bit. The data themselves, when you're starting to use on the data set, there's a lot of things that can go wrong with the data, especially if you're reusing data that are coming from somewhere else. And I think that's one of the things that we have to be careful, what's on the data provenance aspect, on the, what kind of a QC is proposed and you can be reused. So there's a lot of variability on how software will respond depending on those parameters of the data as well. So that's, that flexibility aspect is not the main topic of that workshop, but I think it has to be mentioned here. Data set issues, of course, which are going a little bit in the same sort of direction. If you start to learn on a specific subpopulation and you do a learner, you have to know how is that learner going to predict what's the accuracy of that learner going to be if you actually have a different data set. And that's one of the work that Jérôme did in the lab on looking at those things. And basically the answer is that in some, in quite a few cases, often the learner will actually predict much worse. And that's, at 10, but how much worse? And, and how well those things are generalizable to new data is the question. I will skip that. So what can we do? We can be at that workshop. That's an important thing. So learn about those things. Think about those things, because you have to conceptualize that problem before we can do anything about it. So one thing that I really want to point as a pre-solution, and maybe Tom, I don't think Tom will talk about that, so I just wanted to make sure that it is mentioned here. Maybe, and if it's repeated, it's fine. Repetition is good for pedagogical reason. So the way we can do things is actually, as much as we can, do some sort of pre-registration aspect, where you send the plan of analysis, and you send it, and it is reviewed, and maybe some reviewer will say, why are you using that tool? Why are you using that method? Why not this one? And then maybe we can think of a how do we, incorporate in our plan of analysis that robustness across the different pipelines. Open software pipeline, what can we do? We can, of course, make those software and pipelines as open and as well documented and as well, reused, and with the example and things. So I think there's a lot of sort of energy in terms of development of pipelines and making that open to everyone. So we have now much more ways of actually analyzing and checking that analytical flexibility and how robust are the findings with pipelines that we had maybe something like 10 years ago. I think that's, and there's also like the tools like containers descriptors, the standards, the bit standards, the bits app standards, and all those things are really helpful in that direction of testing and looking at analytical flexibility. In this course, goal number 1, be aware. Goal number 1 is your result may change significantly with the pipeline you are using. Okay, so that is goal, and hopefully getting that goal very well, in your brains. That those results may change with analytical, with some choices of pipelines. We're going to hear about some those platforms that really help on assessing that analytical flexibility, and then hopefully Tom will tell us, how can we possibly do with, let's say, we have several results of different pipelines on the same data set. What kind of a statistical method can we do for, co-analyzing those things? And the machine learning aspect is, I think, will be mostly treated with the panel. So please be ready in your mind to think about that problem in machine learning as well. Last, I have questions for you. One thing is, have you in the past used more than one pipeline to process a data set and publish a data? I just want to a quick show of hands. Who has done many? I would say half of the room has, and maybe that's a recruitment bias here. That maybe those people who have done that are interested to know. But I think you're probably more than the average OHBM audience in that respect. You probably have more, try more things in general. So that's one. That was one question. That's a beautiful answer. Thank you. The second question is, how do you choose your analysis pipeline? what are the rationale with which you, and I've put a couple of things, and maybe you can, raise your hand with like a number, 1, 2, 3, 4, So one is my lab is using this one, and this is the one that has, generally been used in my environment. I think that's a very often taken, that's one thing that might happen often. Or the key reference for my study is using that pipeline. I would just want to reuse the same thing that has been published in this very important paper that, is on my study. Or this is really the well-adapted one. I've tested everything, and really that's, I have a way of assessing that this is really the pipeline that I should be using. Or it was simple to install, simple to use, documentation was well done, and it was published. Of course, all those things are published and reused. So why not this one? Because it's kind of there's a practical aspect and to it. So if you could show, I'm trying to see without the light, what number you're closest to, and I understand that's be 3, 2, 1, 2, 2, 3, 1, 1. 1, 4, there's a 4, there's a 1, 1, 4, 5. There's another reason that I haven't put that Franco is using. Okay, I think there's a diverse thing, but I think my point is that 3 is not often the main reason, right? And I think I would love to, and maybe I will in the future, make a proper survey in the community to see what's going on. But I think that reason here is not necessarily the main one. It's not very often taken. Thank you. That's all for me. You'll be hearing from the analytical platforms, the pipeline platform that can help you assess dot variability, and hopefully we learn how to think about it and do something about it. Thank you very much. Any quick question? I don't know what's the, sorry, I haven't checked the time, so I'm maybe late or early. I'm good? Okay. Any question for me before we move to the first platform?
I think I'll ask one question.
Sure.
So about the last question, which one is the correct answer according to you?
I mean, if you're a scientist, if you want to do the best job ever, I would hope that the number 3 is kind of but we all press by time. It's easier to just reuse. And if you're reusing something that have been used before in the lab, then you have simpler comparison. You have someone who knows how to help you with that specific pipeline. It's a complex problem, and I'm not saying it's but I was kind of hoping that number 3 you really test things and that can go into minus details that is very hard to get from even the pipelines themselves are not super carefully described, and you have to go into old papers and sometimes the implementations has changed, it's super hard. It's super hard. One of the aspects is just highlighting that that difficulty of actually choosing an appropriate pipeline for specific. Or maybe they're all giving you the same answers, and nothing is that doesn't matter then, and that's okay. It's just in many cases I've seen that they are not giving you they are giving you significantly different answers. So that, and not knowing whether they do or not is to me the problem. Any other question from the room? If not, there will be a panel, so think of a possible question and things. There will be a panel, so there will be time to more discussion, and we hope to be making that very interactive. So if not, I think, Satra, you're the first. I don't know if that's it's going to talk about BAPS.